Binomial theorem. You should be familiar with Pascal's triangle, factorials, sigma notation, and expanding binomials by foiling. In this lesson, we will expand higher powers of binomials. We wish to look at the pattern when we expand x plus y to a power. Anything to the 0 power is 1. X plus y to the first is itself. X plus y squared has a middle term of 2xy. When we expand x plus y to the third, we get 8 terms. When we look just at the coefficients from left to right, we get the familiar pattern from Pascal's triangle. Each row begins and ends with 1. The numbers in between are found by adding the two numbers above. For example, 4 plus 6 gives 10. You may wish to stop the video here to write out the next row of Pascal's triangle. Here is the 7th row. Let's show why the recursion in Pascal's triangle works for expanding binomials. Starting with the expansion for x plus y to the third, let's find x plus y to the fourth. We multiply x plus y to the third by x plus y. The first term will be x to the fourth. The next two terms will involve x cubed times y. The total will come from adding two coefficients, the coefficients corresponding to the previous row of Pascal's triangle. We will also get two terms involving x squared, y squared, two terms involving x times y to the third, and finally y to the fourth. When we add like terms, we are adding consecutive coefficients of the previous expansion exactly the same way entries are added in Pascal's triangle. The notation for the coefficients in Pascal's triangle looks like a fraction without the fraction bar. It is read n choose k, which comes from another use of Pascal's triangle for counting the number of combinations of objects, a useful building block for probability. N choose k is calculated from the following factorial formula. The expansion of x plus y to the n is the sum of terms with a coefficient and powers of x and y. Here's an example of calculating 7 choose 4. Also recall that 7 choose 4 is found in Pascal's triangle. Find the row that begins with 1, 7, then count the coefficients from left to right, starting with 0, 1, 2, 3, 4. The corresponding number is 35. This will be the coefficient on x to the third, y to the fourth. Here is the full expansion of x plus y to the 7th using the 7th row of Pascal's triangle. Notice that the exponents on x start at 7 and go down by 1 each time, and the exponents on y go up by 1 each time. We can expand binomials involving constants in the same way. The coefficients come from Pascal's triangle. The powers of x decrease by 1, and the powers on -2 increase by 1. We can then multiply the numbers to simplify to the final answer. To recap, the expansion of x plus y to the n has terms whose exponents add to n. It begins with x to the n. The powers on x are reduced by 1 in each step, and the powers on y increase by 1 until reaching y to the n. The coefficients can be calculated from the factorial formula or read directly from Pascal's triangle.